point right there of that chord is M. That does create a 90-degree angle right there. I've got my protractor. I can prove it to you. All right, it does form a 90-degree angle. Okay, so let's complete the following statement. A line through the center of a circle bisects a chord if and only if the line is perpendicular to the chord. So again, we've got that relationship, that if and only if relationship. That means it can go both ways. So that means if we know that's a 90-degree angle, then that chord is cut in half. Vice versa. If the chord is cut in half, then we know that it's a 90-degree angle right there. Okay? So we're going to use that relationship here to answer the questions that follow on your paper. So first of all, they tell us, suppose that a given circle has a radius of 6 inches. What is the length of a chord that has a central angle of 115 degrees? So I've given you a circle there with the center marked. So you need to copy kind of the angle that I've got up here. It's about a 115-degree angle. We're going to label this, and then we're going to try and answer this question. Yes. Oh, y'all weren't here yesterday. Sorry. Well, thanks for telling me when y'all came in. I always use the version you're asking. Okay. So suppose that the circle has a radius of 6 inches. So let's label that first. If it has a radius of 6 inches, we've got 6 inches here, we got 6 inches there. I don't know what I'm really going to need, so I'm going to label them both. Okay, the question is, what is the length of a chord that's created there? So the chord that's created connects the two sides, so to speak, of the circle that are created by this angle of 115 degrees. So the question is, what's the length of that chord? Well, probably makes sense that we should use what we just did, right? So we just said that if we draw a line through the center of the circle that cuts this in half, then we have a right angle. Okay, we have a right angle. So we actually have two congruent right triangles right here. The one on the left is the same as the one on the right. So that means that not only does it cut that chord in half, it also bisects that central angle. Okay, it also bisects that central angle. So we really just need this angle right here. So if the whole thing's 115 and it's bisected, then what is the angle inside of our right triangle? 57.5 degrees, right? Half of 115. Half of 115. Okay. So we're looking for the length of the chord. We've got an angle. We have one of the sides of the triangle. Bless you. So that means we're going to end up using trig. So let me remind you of our trig ratios. Okay, so we've got SOH, CAH, TOA. Okay, so let's identify what we have and what we're looking for. We have 6. Which side in the right triangle is 6? The hypotenuse. It is across from the 90-degree angle. It is the hypotenuse. We're trying to find the length of the chord, so we are trying to find this length right up here intermediately, okay, in the process. Is that the opposite or is that the adjacent? Opposite, okay? Remember my tip, if you extend that angle symbol, the other leg that it touches besides the hypotenuse is the adjacent, so then that means that the other one is the opposite, okay? It's across from the angle, so it is the opposite. So we need to know the opposite. We have the hypotenuse. Which trig function are we talking about? Sine. Okay, sine is O over H. So the sine of the angle, 57.5 degrees, is equal to the opposite x over the hypotenuse 6. How do we solve that for x? Multiply by 6, because we're dividing by 6, so we multiply by 6. So then we just type this into our calculator, and we need to make sure that what? We're in degree mode. Okay, mine is in degree mode. Make sure yours is in degree mode in case someone from first period or you yourself have reset it. So we get 5.06 for x. Is that our final answer? No, that's only half of the chord. So we have to multiply that by 2 to get 10.12 inches for the length of that chord. Okay, so let's reset the problem. Our radius is still 6, but the central angle is not 115. Okay, the radius is still 6, but the central angle is not 115. Part B says, what's the measure of the arc of a chord that is 8 inches long? Okay, so we're resetting the problem. Our radius is still 6, but this time the chord is 8 inches long. They give us that part. They want to know the measure of the arc. Well, what did we learn yesterday? The measure of the arc is the same as the measure of what? The central angle. So we need to find that angle there. Well, we can't find it the way it is. We got to go back to what we just learned. Bless you. We got to split this into a right triangle. Okay? So we're trying to find that central angle. So we're going to start by intermediately finding that angle in the right triangle down here. Okay? Are we going to use 6 and 8? Bless you. We'll use 6 and 4. Okay? Because 8 is the whole chord. We only need the part of the triangle. So we split that in half. We're trying to find the angle. Let's identify our sides again. 6 is still the hypotenuse. How about 4? Is that the opposite or is that the adjacent? It's still the opposite. Okay, so we're still using sine, but this time the question is, what is our angle? So I'm going to label that as theta. We use theta, the Greek letter theta, to represent angles a lot. So the sine of theta is equal to the opposite over the hypotenuse. What do we do when we're solving for the angle? Second sine, the inverse sine of 4 over 6, the opposite of sine. We can't divide by sine. Sine is not a number. Sine is an operation. So we use the opposite of sine, which is the inverse. Inverse sine of 4 over 6. So theta is 41.81 degrees. But that's just the angle in the triangle. We need the whole central angle. Well, we learned in the last example that that central angle is also cut in half. So we multiply it by 2 to get 83.62. Did I do that correctly? Degrees for that central angle. And the central angle has the same measure as the arc. Okay, so that is the answer, 83.62 degrees. Now, this next question goes along with part B, okay? It doesn't have a new letter. This is an extension of this problem. What is the perpendicular distance from the center of the circle to the chord? Now, that sounds really intimidating, but let's break it down. Perpendicular distance from the center, let me use red so it stands out, from the center to the chord. And it's perpendicular. We have a right angle right there. We're just talking about that distance. Anybody have any ideas on how we can find that distance? Pythagorean theorem. We could use another trig function. We could use another trig function now that we know the angle, but the simplest thing would be to use the Pythagorean theorem. We've got the hypotenuse, we've got one of the legs, we're looking for the other leg. So let's set that up. We've got a squared plus 4 squared equals 6 squared. So a squared plus 16 equals 36. Subtract the 16, a squared equals 20. Take the square root. Now, I know you can do this in your calculator, but let's take an opportunity to review simplifying radicals. 20 is 4 times 5. The square root of 4 is 2. 5 is not a perfect square. But typically, we're kind of talking about an application problem right here, so 2 square roots of 5 doesn't mean a whole lot to us. So let's find out what that decimal approximation is. It is approximately 4.47 inches. And that makes sense, because that's less than our hypotenuse. Okay, let's reset the problem one more time. Let's look at example C. It says the perpendicular distance. This time they're giving us that piece of information. The perpendicular distance from the center of the circle to a chord. So let's draw the chord in there and draw in that perpendicular segment. It is 4 inches. Our radius is still 6. That has not changed. That was given to us at the very beginning before we started, so that's the same. What is the length of the chord? So we've got the hypotenuse, we have a leg. Let's find the other part. Well, how is this any different from what we just did? It's not. They're just in different spots. It's still 16 plus b squared is equal to 36, so b squared is still going to equal 20. So B is approximately 4.47. Why did I use B? I already labeled it as X. Whatever. Not a big deal. What is the length of the chord, though? Is the chord length 4.47? No. That's half of it. So we got to multiply it by 2. 8.94 inches. Okay, so a little bit longer than the chord from the previous problem. And then one more question about this one. What is the measure of its central angle? So let's start with the angle inside the triangle. Now, you can use the 4.47, but let's, in case we did something wrong in calculating that, let's use the 4 and the 6. So the 6 is still the hypotenuse. What is 4? Adjacent or opposite? It's adjacent this time. The 4 is adjacent to that angle. So adjacent and hypotenuse is cosine. Cosine of the angle is equal to the adjacent 4 over the hypotenuse 6. So we use the inverse. And we get 48.19 degrees. But that's just the angle inside the triangle. It wants the measure of the central angle. So we need to multiply it by 2 to get 96.38 degrees for the measure of the central angle.